Hi, this is Terry here again. In this video, I'm going to be looking at moments, right? Um, just to remind you guys, so I'm the official author of the CSEC Physics study guides for CXC, right? Currently, I have a Form 5 class that I'm preparing to write exam in May 2020. This class is every Saturday from 9:30 to 11:30 a.m., right? And this is in Union Hall, San Fernando, Trinidad, by the way, right? And if anyone is interested, you can call me at 784-2059, or you can send me a WhatsApp message, okay? So let's begin. So, the moment of a force. The moment of a force is the turning effect of a force, right? So, take for example, you are trying to open a door at the door handle, right? That force you apply to the door is producing a turning effect, right? And the door opens. Now, in the exam, you will be asked to define or explain what is meant by moment, right? When they ask you to explain what is meant by moment, moment is defined as a force multiplied by the perpendicular distance from the pivot, right? So for example, let's say we're looking at the same door example, right? So this is a door and this is the door hinge here, right? And you apply a force F, right, which is at right angles to the door. This force will produce a turning effect in this direction, or what we call a clockwise movement. So the moment of that force is given by the product of this force multiplied by this distance here, which is the perpendicular distance from my pivot, right? Remember I said this is my pivot here, or my fulcrum. So sometimes in the multiple choice you may be asked what is the SI unit of moment. Now because we are multiplying force and distance, force is measured in newtons and distance is measured in meters, so the SI unit for moment is Newton meters, right? Now another thing that you're going to be asked is what is meant by the principle of moments. Now the principle of moments states that the sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about the same point, right? Let's missed out the T here. So what does that mean? Easiest way I can explain this is, suppose we have a fulcrum here and we have a long bar on this fulcrum, right? And we have a force here, let's call that F1, and we have another force here, let's call that F2, right? Now this is my pivot here, and let's call this distance here D2, right? And let's call this distance from here to here, right? That's from the pivot to F1. Let's call that D1. And on the other side, let's have a force here. Let's call that F3. And we have another force here. Let's call that F4. Right? And this distance from the fulcrum here, let's call that D3. And this distance here, F4 from the fulcrum or the pivot, that's this. Let's call that D4. Right? Now we want to apply the principle of moments, or we want to explain what is meant by the principle of moments. So F1 is going to produce a clockwise movement, right? Visualize when I apply F1 to the bar, it's going to rotate in a clockwise direction. Similarly, F2 is going to produce a clockwise movement as well. So what we are saying, the principle of moment saying that the total clockwise movement, so total clockwise moment is equal to the total anti-clockwise moment. Right, there's a S, there's a S. Right, so my clockwise moments. So we just said that F1 and F2 produce a clockwise moment. So F1, the moment of the force F1 is F1 multiplied by D1. Right? But that's just one of the clockwise moments. F2 is also producing a clockwise moment. So it's plus F2 multiplied by D2. Right? Now let's look at F3 and F4. When we apply the force F3, we're going to rotate this way. So you're going to get an anti-clockwise moment, right? So that anti-clockwise moment will be F3 multiplied by D3, right? Similarly, F4 will produce an anti-clockwise moment. So that is plus F4 multiplied by D4, right? So this is essentially what the principle of moments is. The sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about that same point, right? Now, I'm going to do some examples to show you how to apply the principle of moments. Now, please, in the exam, do not confuse moments and momentum, right? Momentum is a product of a body's mass and velocity, right? Moments is something different. So let's look at this question here. Right? So we have the forearm is a lever which the bicep muscles provide an upward force which can raise the arm and carry a load. The diagram below represents the forearm as it holds a load of 60 newtons. And the forearm has a weight of 25 newtons, and the center of gravity G of the forearm is marked along with the point P at which it pivots on the adjoining bone, right? So basically, we have a diagram here. We have the arm, which is holding an object of weight 60 newtons, right? Now, the first part of the question, they want us to use the principle of moments to calculate the force B exerted by the bicep to hold the arm and load stationary. So this is the force that they want us to find. They want us to find B. Now, first thing we need to do with these questions, we need to figure out what are we going to use as our pivot. Now visualize this, you trying to lift this object here, right? It means that the whole arm is being pivoted at this point here, which is P, right? Now, once you identify what you're going to use as your pivot, you need to identify all the clockwise forces and all the anti-clockwise forces. So the 60 Newton force, right, that is going to produce a clockwise moment. The 25 Newton force is going to produce a clockwise moment, right? And all of that is about this pivot P. In the case of B now, B is doing this. B is trying to lift the arm. So therefore B is anti-clockwise, right? So let's look at this again. So we want to find the force B. So let me go to this here. So like I said, 60 Newton is clockwise, 25 Newton is clockwise, and B is anti-clockwise, right? And this is what we're going to use as our pivot. So taking moments about the point P, that's what we're going to say. So taking moments about P, right? So we have, so we need to write this, right? Sum of clockwise moments equal the sum of the anti-clockwise moments. So all questions that involve moments that we're trying to solve using the principle of moments, we're going to be using this. So my clockwise moments. So we said the 60 Newton, so that is 60 multiplied by the perpendicular distance from the fulcrum. So that is point. So we have to add this distance here plus this distance here. So that's 0.2 plus 0.15, which will be 0.35 plus, we need to take care of the 25 Newton force now. So that 25 Newton, we have to multiply that by the perpendicular distance from P, which is 0.2, right? 0.2. Now the anti-clockwise now. We don't know what B is. B is what you're trying to calculate. So let's call that B. Multiplied by my perpendicular distance from my fulcrum, which is 0.05. 0.05. Alright? So let me just work that out for you there. So that is 60 multiplied by 0.35. Right? That gives me 21. And then 25 multiplied by 0.2. That gives me 5. Plus 5 equal 0.05 B. Right? So this is really 26 is equal to 0.05 B. So therefore the force B is equal to 26 over 0.05. Right? And that will give me, so that's 26 divided by 0.05. And that gives me 520 Newton. Right? Hopefully that's correct there. And that number is looking a little big. So it's 520 newtons, right? So that's the amount of force the bicep needs to use in order to lift the object, right? Or to keep the arm horizontal in this case here. Alright, so let me just double check that. So that's 60 by 0.35, 25 by 0.2. Just double check, make sure that answer is correct. 60 multiplied. Right, so please get into the habit of double checking your answers as well in the exam. Right, so that's 26 divided by 0.05. Okay, so 520 newtons, right? So that's the first part. So they said using the principle of moments, calculate the force B. Now, the next part, part 2, they said the adjoining bone pushes the forearm, pushes down on the forearm at the point P with a force R. Right, by considering the upward and downward forces, calculate R. So let's go back to this. So what they are saying is that you have B. B is acting upwards. You have the weight of the arm, which is acting downwards. And you have the object you're lifting, which is also acting downwards. And they said that the bone, right, is being pushed here by a force R. Right? And you want to calculate the value of R. Now, in this case here, all we need to do is say total downward force equal total upward force. Alright, we can make that statement because the arm is horizontal. Right? So, my upward forces, we have B. B is the only thing that's acting upwards. So that's 520. Sorry, we're looking at the downward forces. So this is R plus 25. Right? We're looking at the downward forces. R is acting downwards. The 25 Newton is acting downwards. Plus 60 is also acting downwards. And my total upward force is what we got as B, which is 520. Right? So B, this is here. We got 520 just now, right? So therefore R plus 85 equal 520. So therefore R is equal to 520 minus 85. So therefore R is equal to 435. So R is 435 newtons, right? Hopefully my answers are correct. You can always double check for me, right? So let's do another example. So in this one here, we have the diagram shows a wheelbarrow containing a load of sand, right? The container and the load are pivoted at P and have a mass of 40 kilograms. Their center of gravity is 0.5 meters from P and the handles are 1.4 meters from P. So basically everything they're giving you here is on the diagram. The handles are being held so that the wheelbarrow is in equilibrium. Now when they say the wheelbarrow is in equilibrium, we have it in a stationary position, right? It's not moving up, it's not moving down. So they said name the principle that must be satisfied for the barrow to be balanced and explain how this principle applies in this case. So here's what's going on here. So the principle they're talking about here, obviously, is the principle of moments, right? So they said name the principle, that's the principle. Now we have to explain how that principle applies in this case. So look at this. So the wheelbarrow, you're going to have to apply a force here, which is upwards, right? This force is going to produce an anti-clockwise moment about the point P, right? This is my pivot here. And the weight of the sand is acting like this. So therefore this here, so this is my weight of the sand, and this is a force, this is the force here that I'm going to apply upwards at the handles. So the weight of the sand produces a clockwise moment. So you have the weight of the sand produces a clockwise moment, and that clockwise moment must equal to the anti-clockwise moment, which is the moment produced by the force being applied at the handles, right? So now they said calculate the upward force which is being provided by the handles. So in order to work this out, so let me just go to a blank page, right? So you want the upward force being provided at the handles. So the question is really asking, what is this force here? So let's call this force F, right? Now they told you the mass of the sand. Let me work that out here. So the mass of the sand is, how much they said? 40 kilograms. So the mass of the sand is 40 kg. Now you need to be careful with this because we are dealing with moments, so we're talking about forces. So we need to find the weight of the sand. So weight is equal to mg, right? That's the formula to find weight. And it's 40 kilograms multiplied by g. I'm going to assume g is 10, right? That's the gravitational field strength on Earth. So this is 400 newtons, right? So the weight of the sand, as acting this way, is 400 newtons, right? So now we want to find F. So we start off, like I said, all these questions, we have to put total clockwise moments, or the sum of the clockwise moments, total clockwise moments equal total anti-clockwise moments. Right, my clockwise moments in this case, right, the weight of the sand is going to produce a moment this way, which is clockwise. So my clockwise moments here will be 400 multiplied by my perpendicular distance, which is 0.5. And that is equal to your anti-clockwise moments here. So this force is going to produce an anti-clockwise moment. So it's F multiplied by the perpendicular distance, which is 1.4. So therefore, F is simply equal to 400 by 0.5 over 1.4, right? So therefore that force there, let me work that out for you. So that's 400 multiplied by 0.5 divided by 1.4, and I'm going to get 1, let's round it off to the nearest alright, so this is 143 newtons. Alright, so that's my force F at the handle, 143 newtons. So let's see what else they ask. They said calculate the upward force at the axle P of the wheelbarrow. Right? So let's go back here now. So they want to find the upward force. So what they're saying is that we have an upward force here, right, at the handle P. At the pivot P. Right? What is this upward force? Now again, we know that they told us in the question that the wheelbarrow is in equilibrium, meaning that it's not moving. Right? So we, just like with the bicep question just now, we can say total upward force equal total downward force. Right? My downward force in this case is 400 Newton. Alright? My upward force will be F, which is 143, plus the upward force at P, which is, let's call that P. So therefore P is simply equal to 400 minus 143. Alright, so therefore P, so that is 400 minus 143, and that gives me 257 newtons. So 257 newtons. right? So the upward force at P is 257 newtons. All right. So I hope you are following. You can always practice the questions, try to work it, and then look at the solution. Let's look at the next one here. So in this question here, we have a tray being held horizontally by a waiter, right? The tray has a weight of 6 newtons. So basically they've given us all the dimensions and all the weights on the diagram. They said use the information to find the force provided by the waiter at P and the upward force the hand exerts at T, right? So you want to find, the first thing we want to find the force at P. So let's find the force at P. Now let's take T as my pivot, right? So we're taking moments about T. So taking moments about T, right? And we say the total clockwise. Again, all these questions start off the same way. Sum of the total clockwise moments equal total anti-clockwise moments. Alright, so my total clockwise moments. So since we're using T as a pivot, we need to look at each of the forces and see what is happening. So the 6 Newton is going to be a clockwise moment. The 3 Newton is going to be a clockwise moment. And this force here that we want to find, where the thumb is pushing downwards, right? That force is actually moving this way. So therefore that's an anti-clockwise moment. So all the clockwise moments will be, let's start with the 3 Newton. So this is 3 multiplied by my perpendicular distance, right? Which is 40 cm, right? So we can work in cm or meters, it doesn't matter. So this is 40, right? Plus we have the 6 Newton multiplied by this distance here, right? Which is 30 minus 5, which is 25 centimeters. Right, and my anti-clockwise moments, we have one of them, which is the force P multiplied by that distance there from the fulcrum, which is 5. Right, so this is 3 by 4, that's 120 plus 6 by 25, that gives me 150, which is equal to 5P. Right, so P is simply equal to 120 plus 150 all over 5. So therefore P is equal to is equal to 54 newtons. Alright, so that's the downward force we are applying here. It's 54 newtons. Now they also want us to find the the upward force the hand exerts at T. Alright, so let's go back to this. So we want to find, they're asking you to find the upward force being exerted at T. That's here. Alright. Now again, because the tray is horizontal and it's not moving, right, we're going to apply the same thing we applied in the other two questions. We're going to say the total upward force. So total upward force equal total downward force. Alright, so my total upward force, the only thing I have acting upwards is F, so that's F. Alright, we have several forces acting downwards. We have P, which is what we worked out just now. We got 54 is acting downwards, the 6 is also acting downwards, and the 3 newtons is also acting downwards. Alright, so that will give me a total of 63 newtons. Alright, so that's how we work that question.